What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. Number 7 here, looks like I have R2 ALH. What that means is we're working with dipole. So we've already seen this before, but I just wanted to give you this problem in a different kind of context. They could write it out as R2 ALH, they could write dipole, but essentially you should know my amide turns into an aldehyde. For the next one, I have another reducing agent. So this is lithium aluminum hydride. Anywhere you see a carbonyl, that carbonyl is going to be reduced down to an alcohol functional group. So this guy over here will turn into an OH. I'll have some source of H come in here, kick this up, protonate the O. And then likewise over here, I can come in here, kick this up, bring it down, kick this out. And then this group is special because there was an aldehyde intermediate, but it's going to keep going until it becomes a primary alcohol. Expect to see this. Let's move on to the next one. All right, so now we're on our synthesis problems. So make sure you guys are working this out on your own. Give it a try. Really work through these problems before you look at the answers. So I have stereochem obviously is involved. I went from into the board to out of the board, and it looks like I have some sort of nitrogen at the end of the problem. So we've been working a lot with nitrogens. Let's go ahead and see what we can do here. So I'm going to react this with NaCN, right? Because we're trying to get to that other stereochem. I know NaCN is going to flip my stereochem. It's going to do an SN2 reaction. Let's do that in DMSO just to give it higher yield. So that's going to give me the CN group that I'm looking for. If I do hydrolysis, I can actually turn this into a carboxylic acid. Why might I do that? It's because I want to turn it into a reactive carboxylic acid derivative. So I'm going to do SOCl2 and pyrimidine. That's going to give me the most reactive carboxylic acid derivative. There we go, acyl chloride. Now I can turn this into an amide, right? We kind of seen what's happening here. If I react this with two equivalents of some sort of nitrogen, in this case it looks like I have CH2CH3, so I want two CH2CH3s, right? Because of the mechanism, I'm only going to be adding one of these guys, but I need two in order to go through the full mechanism. So that's going to give me an amide in the place of the acyl chloride. Here's that amide. Now all I have to do is reduce this amide down into an amine. Right here, these are two new H's, and we've been talking about this for a while in this problem. So this is LiAlH4, THF, H3O+, and that will give me this. So that's how I get stereochem involved, and that's how I reduce the amide down to the amine. Next up, we have a carboxylic acid, and we're trying to convert it into an aldehyde. So a couple ways we could do it. I could react this guy simply with SOCl2 in pyrimidine. It'll make a very reactive acyl chloride. And then from there, all I have to do is LiAlOR3 with a source of H, put that in some diethyl ether, and add some H3O+. That's the quickest way to do it. Now the R group is a little bit longer. Dr. Nasiri writes that in her lecture notes. Or we could have gone through, could have made this, let's see, let's also do that, SOCl2 in pyrimidine. So start with a very reactive carboxylic acid derivative, turn that into the amide. So we worked on that before. In the previous problem, I could take two ends, just like this, and then I can react So that'll give me the amide. And I know that I can get rid of an amide and turn it into the aldehyde with dibol. Perfect. So those are two options you could have done. This one's my favorite. So for this problem, we start off with a ketone, and I'm trying to basically make a carboxylic acid, but a few carbons away. So you got to be very creative here. First thing I want to do is Br2 and some acetic acid. This will do acid catalyzed bromination of ketones. So this will give me a Br group alpha to the carbonyl. If I then react this with a big bulky base, so let's do tert butoxide. Right, this goes back to 118A, 118B. Here, grab the proton, break this, form a double bond. I just generated a 1,4 double bond. So here I have 1, 2, 3, and then 4. I have a double bond here now thanks to the E2 mechanism. Now with that double bond, I can actually add and do 1,4 addition. So let me do 1,4 addition with NaCN in some acid and a little bit of heat. So let's go ahead and do, we'll put the CN here, and then the last step is hydrolysis. So that's H3O plus and some heat. And that's going to turn the cyanide group into a carboxylic acid. All right, guys, that's everything for today. Thanks for tuning in, and we'll see you next time.